In this video, we solve a problem related to discrete time signal and systems. This content is designed for undergraduate students taking signal and systems or digital signal processing. In this question, it says that the system is LTI. It gives the impulse response, also gives the input in the form of the unit step, and it asks us to find the output. To solve this question, we need to remind this point. The output of an LTI system is equal to the convolution of the input with the impulse response. Based on the definition of convolution, we can write it as a summation of x of k multiplied by h of n minus k. Or we can also write it as the convolution of the summation impulse response with the input, which is equal to summation of h of k multiplied by x of n minus k. Now, which one we use depends on the problem and which form makes it easier to solve. In this question, we use the convolution of the impulse response with the input. Here, we also remind how the unit step signal looks in the discrete time systems. This is the shape of the unit step. For n values greater than or equal to 0, it's equal to 1, and for n values less than 0, it's equal to 0. As you can see in the problem, the impulse response is equal to 1 4 times from 0 to 3, and 4 times 4 and 5, it's equal to minus 2. Then we can write the summation from k equal to 0 up to 5, and then we substitute k in the expression. And the result is obtained in the following form. If I want to give an example, if you set k at 1, this term becomes h1 multiplied by u n minus 1. And in the same way, we continue. Now we substitute the values of h. H at times 0, 1, 2, and 3 is equal to 1. So the result becomes un plus un minus 1 plus un minus 2 plus un minus 3, and h at times 4 and 5 is minus 2. Now we need to draw this one by one to be able to obtain y. If we draw the first one, it's un. For n greater than or equal to 0, it's 1, and for n less than 0, it's 0. And its plot looks like this. The second function is un minus 1. That means we have to shift un 1 unit to the right. Therefore, at n equal to 1, un is 1, and this adds 1 more. So it becomes 2. At n equal 2, it becomes 2 as well. And in the same way, it continues. The next function is un minus 2, which starts from n equal 2 and adds 1 unit to the previous values. In the same way, the next one is u n minus 3, which starts from n equal to 3 and is added to the previous one. The next term is minus 2 u and minus 4, which starts from n equal 2 and subtracts 2 units from the previous values. And finally, minus 2 u and minus 5, which starts from n equal to 5 and subtracts 2 more units from the previous values. Now, if we want to write the simplified and final result, it will be like this. At n equal to 0, we only have 1. At n equal to 1, we have the value 2. At n equal to 2, we have the value 3. At n equal to 3, we have the value 4. At n equal to 4, we have a value 4 and a value minus 2, and their sum becomes 2. At n equal to 5, we have 4 and minus 4, and the sum becomes 0. And for the times after that, it will also be 0. If this video was helpful for you, feel free to check out the other videos on this channel for more in-depth explanations.